Hi, this is Josh with Sanford, and I wanted to talk real quick about my MALang project because you're probably on my portfolio, and I figure it's better to quickly show you this and you get an understanding of how it works that way than you needing to go read through it all yourself. Of course, feel free to search the GitHub. You're going to find the code, and you're going to see, okay, we're deep into a first version of a parser, which is good. We have a Lexer and we have a parser. You can see it's built on states, and we got a lot going on here because this is a music programming language, and there's two different kinds of objects. There's function trees, and there are musical objects, or voice objects as I call them. So you'll see there's quite a lot to this, and what we'll be looking at in the demonstrations are me printing the abstract syntax tree that is generated by parsing. And what we're going to do is we end up parsing, where's the parse function? We end up parsing over this get next entry function, which is going over all of the tokens that are fed by the Lexer. And you can see that in the get next entry function, which is what you're looking at right now as I'm scrolling up, we handle all of the switch cases, and there's quite a lot going on. We're wanting to make sure everything works well. So let's go up to our application. Here's our web app. And very quickly, I just wanted to describe what would an object look like. So in my language, we start a musical voice with our curly braces, our lovely curly braces that we all love. And it's sequential. So each musical object is separated by a comma, and just like in music, one thing has to happen for a certain amount of time before the next thing can happen. And so every object has to have duration in my language. So say if you wanted to specify for 4 quarter notes, just don't do anything. Then you just specify our square brackets with /4, so 4 quarter notes. But say we wanted to tell the musician we're in the key of C. That is our home note. Okay, and we want there to be a harmony played for this 4 quarter notes, which is a major chord. And it's going to be the major chord over the first scale degree of our home. Okay, so what we'll do is at the beginning we define that our home is C, and then the pitch is the bass in this case because we're expressing a figured bass harmony like the Baroque era, but we're actually going to use all 12 numbers. So from one C to the next C, an octave repetition, there are only 12 notes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we're trying to specify, you should be playing in whatever key you're in this case C because we define it, play a major chord over the first scale degree, then we're going to say the first scale degree is 1, and then the harmony over it is 8/5. And this is very similar to figured bass notation, which would actually call it a 5/3 chord because they use the 7 notes of the major scale rather than the 12 notes of the chromatic scale. But I want to upgrade this in modern terms to use all 12 notes. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5. And what this would just tell the musician, it doesn't tell them anything super specific other than we're the sonority of a major chord over the home key is what's being looked for here. So we can tokenize this, and you can see that it breaks everything down into its necessary tokens. And I can show it parsed. So you see that the first entry in the abstract syntax tree is a function tree with home being the operator and parameter C being the parameter. So this is like Lisp S expressions. The first item after an open parenthesis is the operator, and everything else in the list is a parameter for that operator. But you can nest other lists inside of your root operator. So you can nest functions inside of functions, just like in Lisp. So we have this voice that starts with the curly brace, and then we have a musical object. So you can see that the next abstract syntax tree entry, let me get rid of our keyboard here. Sorry about that. You can see that the next entry is a voice object, and its pitch is 1, and it doesn't have any octave shift, and we have our figurations, and we have a duration numerator and denominator. So that's great. And see, maybe we wanted to add another object behind it. And this time we just want to say, hey, you can play any major chord sonority, and I'm not even going to specify the bass note. And a lot of times this is what happens in Partimento. You're just supposed to understand, oh, well, if nothing changes, then just, stay on the 1. So we'll do that for another quarter. As long as you have a duration specified, as long as you have, something in these square brackets, it's a valid voice object. So I'm going to reload this, parse code, and you'll see that we have a new object underneath the other voice object, and it has a null pitch because it's null. Okay, cool. Let's give an example of what it might look like to put a expression at the end of a voice object. So maybe let's just keep working with this same voice object. Maybe you want to specify that you also, from this point forward, want a hi-hat to occur every quarter. I've not implemented this. I'm just imagining something that could exist. If we parse this code, you'll see that you can also append musical objects with functions, which is very useful. We have operator and parameter. Very nice. You can also see that my parser is handling function nesting. Let's do some function nesting. So let's say 1, let's just do silly stuff. 2, 3, 4, 5, 6. So what is this going to do? Oh, look at this. I need to close this extra parentheses here. So this should create some nesting for us. I wish I could draw it for you here because it's easier to think of it that way, but this is 1 is the root operator, and then its second parameter is this function where 2 is the operator of that function, which has its own parameter, and then another function nested inside of it, and then just another parameter out here. So to show you that my parser is taking care of this and building up this tree correctly, you can see in the print output that we have the operator, nested operator with its parameter. This operator has a nested operator and parameter as well. It all gets closed up in this whole list right here, and then we have another parameter at the end. And so this big box represents the entire outer list from this parentheses to this parentheses. So you can see that quite a lot is going on in this musical programming language. And what if we wanted to just do a... you can notate simple melodies. So let's notate a melody. Da, 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 da. That'd be a very simple melody to notate. So if, I can bring back the keyboard here. So that's 1, 2, 3. Sorry, 1, 3, 5, 3, 1. So we can just make a little outline. 1, 3, 5, 3, 1. And this is 1, 2, 3, 4, 1, 2, 3, 4, 1. So each of these is 1 quarter note. So then you would specify a quarter note with each of them. And very quickly, we have a little musical piece written in this language. Now, I am highly interested in using this language to do figured bass stuff and partimento stuff and research alongside the partimento research that's being done in musicology right now, because it's new and exciting stuff, and there's a lot of very cool pedagogy going on in the Renaissance and Baroque period around this stuff that was lost until now. So this is my current programmatic interest, and I hope that you find it interesting or at least informative about my technical ability and my possible usefulness at your organization. So thank you for watching, and have a great day.